So, dear friends, again I welcome you in this afternoon. Today's uh, 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 today is 4th July. Oh, sorry, today is 4th April 2024, and now it is 4:30 according to Indian Standard Time.
Okay,
Now,
sir, it is the 4th of April, but is also the 25th of the Ramadan Mubarak.
oh yes, same to you. Happy Ramadan, Mubarak Ramadan.
Okay,
Ramadan
thank you, sir.
Mubarak to you. So now we know we will do some exercises. There are two parts. Second part I will not do here. You can try yourself. If you have any problem, you can do second part. But first part I wish to discuss with you. This is very important, practical. If you are careful in listening, and you will be able to learn it more effectively. Now, exercise on seeding rate, seed germination, percentage seedling emergence, and percentage spacing and plant population. So friends, here it will be somewhat different from what you have learned in rice. So now you see yourself, you see how it is different. Seed germination and field or seedling emergence. Now see what is the difference between seed germination and seedling emergence. Seed germination is simply reactivation of metabolic machinery of seed, resulting in emergence of radicle and plumule, the sprouting of a seedling from a seed. So germination is only sprouting. The new plant comes out from the seed. That is germination. But germination does not mean that your seed, if seed is there in the soil, it has germinated, but it is never necessary that this seed will come outside the soil. So if it is coming outside the soil, then we call it seedling emergence. And seedling germination is just the sprouting of a seedling from a seed. So seedling emergence is growth of plumule. Plumule is actually shoot part, and radicle is the root part which will make the root, and plumule will make the shoot part. So seedling emergence is growth of plumule towards the soil surface and coming out from the soil making a shoot. So this is the difference between seed germination and seedling emergence. Friends, seedling emergence is also called as field emergence. Field emergence. Now, factors affecting field emergence means many times germination is there. You can see on the right side, the seed may germinate, but it may not come outside the soil. So seedling emergence may not be there. What are the reasons why there may not be seedling emergence? So first thing is that seed health and size. So seed is not very healthy. It has germinated, but its size was very small. Small size means it did not have sufficient food reserve for the new plant. So then plant may not come outside the soil. Then there may be some soil factors which can stop this seedling from coming out, like moisture. There may be short of moisture or more moisture, depending upon the condition. Compaction, soil compaction is there, and plumule is trying hard to come out from the soil, but it does not come out because of soil compaction. There may be formation of crust, and soil structure is not good, and there may be salinity. So some soil-related factors are also there, which stop or which prevent the seedling to come out from the soil. Then comes the sowing depth, seed bed preparation. Sometimes you have done very deep sowing. Because of depth of sowing, more depth of sowing, seedling may not come out. It will die on the way. Seed bed preparation. Sometimes seed bed preparation is not good. Therefore, the seedling may not come out. Environmental conditions can also affect the field emergence or seedling emergence, like temperature, herbicide application. Sometimes undesirable herbicide can stop or can kill the emerging seedling. Insect pests and disease can also affect the field emergence or seedling emergence. So you can see what are the factors that affect the field emergence of seedling. The seed emergence rate, that is germination. Seed emergence rate is germination, and emergence of germinated seed. Field emergence are two different values. Seed emergence means germination, and the field emergence means coming out from the soil. So these are two different things. The percentage emergence of planted seed is based on the two values. So overall, this percentage emergence or field emergence based upon the germinated seed or seed germination percentage and percentage emergence of the germinated seed. And it can range from 90 to 95%. Therefore, knowledge of both is necessary to decide the optimum seed rate. Now you see, germination rate is written by seed company. Most of the time, if you see the registered seed or certified seed, the seed company will write that so much is the moisture percent, so much is the germination percent, so much is the purity of the seed. But many times they do not write, or not many times, but always, they do not write the field emergence. They give you data on just germination percentage, but never on the field emergence. So this value is important because it can reveal, help in getting the optimum population and also find out the reasons for it. So therefore, knowledge of field emergence is equally important as the knowledge of the seed emergence or germination. So friends, you can see this formula is very, very important. Field emergence of planted and germinated seeds. Planted means you have done the sowing, and germinated seed. So you can see percentage seed emergence. Plant population after emergence. Plant population after emergence divided by seeding rate. What was the seeding rate? Plant population can be measured as soon as plants emerge by counting number of plants in a specified area. Now you need to count the plant, how many plants have emerged or field emergence is there. So for this, you can count the plant in a meter row length. In agronomy, in your experiment, you must have done it. In 1 meter row length or 2 meter row length, you can count the plant, how many plants have germinated. And you also know the seed number, or you also know the seed rate. So based upon this, you can calculate the percentage seed emergence. Many agronomists recommend measuring the plant area 0.1% of the field. If you have 1 hectare area, in 1 hectare area, you need to measure 10 meter square. This is the sampling area, 10 meter square. So sampling area is generally 0.1% area of the field. Now, field emergence of planted germinated seed, distance along a row that represent 1/11th of 1 hectare, that is 0.1%, depend on the row width. Now you need to decide the length of the row from which you need to collect the sample, or you need to count the seedlings. So actually the area is 0.1%. Then how to convert it into the row length? So that will depend upon the row width. Now you will see how we can do it. For a 20 centimeter row, suppose the row to row distance is 20 centimeter. The length of the row for 1/11, 1/1000 of 1 hectare is 50 meter. So how this 50 meter has come? 10 meter square is the area. As I told you, in 1 hectare, you need to record, sample, or count the seedlings from the 10 meter square out of 10,000 meter square area. So 0.1% of 10,000 meter square is 10 meter square. So now you know the area is 10 meter square. You also know the row length, row width. Row width is 20 centimeter. Now you can calculate the row length. So see the formula. 20 centimeter can be converted into meter. So it is 0.2 meter is equal to 20 centimeter. And L meter, L is the length of the row from which you can count the seedlings. So L we do not know, but is equal to 10 meter square. So 0.2 m into L, L means length of the row, into meters is equal to 10 meters square. So L is equal to 10 divided by 0.2 m. Therefore, 50 meter. So width in meter into length in meter. So now you know that in the 50 meter row length, you need to measure the plant. You need to count the plant in the 50 meter row length. Your area is 100 by 100 meter square. And the row length, anywhere in the center, you can take 1 row and 50 meter length. You can count the plant in 1 hectare area. According to this, you can convert, you can know the row length for your experiment and anything else. Do you have any problem in understanding this point? Hello, anybody? Is it clear to you?
No, sir. 0.1%. I don't know. 0.1% from which place we
Yeah.
take it.
Yeah, okay. Now you see, now there is one numerical I just wish to give you, and you can see this. Calculate the percentage of germinated seed that emerged from the soil. Given the seed germination rate as 95%, the seeding rate is 90,000 seeds per hectare. This is the number of seed, and germination percent is 95. So instead of weight, here the seed number is given, seeds per hectare, and the post-emergence counted plant population is 80,000 plants per hectare. This means you have done sowing of 90,000 seed, but finally emergence was 80,000 plants per hectare. What would be the percentage emergence of germinated seeds? Percentage emergence of germinated seed you need to calculate. Now, just summary is here. Seed germination rate, 95%. Seeding rate is 90,000 seeds per hectare. Seeding rate means sowing rate. Then plant population, field emergence is 80,000 plant. So that means the 10,000 seeds could not become into a seedling. In some cases, germination may be poor. In some cases, there may be no field emergence. So now we want to calculate the field emergence, and it is here you can do it. Number of germinated seeds per hectare into germination percentage. So 90,000 seeds were sown. Germination percent was 95%. 95% means 0.95. You multiply these two, you get 85,500. So many seeds, 85,500 seeds were germinated. Now, out of these 85,500, you see 80,000 came out. They shown the field emergence. So now, out of 85,500 germinated seed, emerged seedlings are 80,000. Thus, out of 100 germinated seed, because you want to calculate in percentage, emerged seedlings will be 80,000 into 100 divided by 85,500. Therefore, 93.6% is the field emergence. Now, I made a formula. So if you do not want to do these kind of calculations, then you can see the formula, PEGS, percentage emergence of germinated seed, percentage emergence of germinated seed. So you can see field emergence divided by seeding or planting rate or sowing rate, and it is further divided by percentage germinated seed divided by 100. So now you put the values. Here field emergence was 80,000 and the seedling or planting rate was 90,000 seeds, and whole divided by 95% was germination. So 95 by 100 into 100. So you get 93.6% PEGS. PEGS means percentage emergence of germinated seed. So do you have any problem in this?
Sir, now exactly it is
sir.
clear.
I got it.
Is it clear? So these are really, you won't believe.
Sorry, sir, your mic is missing.
Yeah. Can you hear me now?
Now, yes, sir, you are audible.
There was some disturbance. I don't know how it has happened, but you have seen this exercise PEGS, percentage emergence of germinated seed. This is the formula. I'm sorry. So this is the formula you have seen. Now I give you one example, and you please do it. Do you want to do it? Determine the percentage of germinated seed that emerged from the soil if the seed germination is 90%. In the last case, it was 95%. And now the seeding rate is 75,000 seeds per hectare. And the post-emergence counted plant population is 60,000. So I think it is again simple. You can put the values of field emergence, 60,000. Seeding or planting rate, 75,000 seeds were sown in 1 hectare, whole divided by 90%, you get 88.9%. So this is the percentage field emergence of germinated seed. Now, next numerical is if rice planting was done at the rate of 500,000 seedlings per hectare and plant population at fourth day was 450,000 plants per hectare. So here you see, initially there were 5 lakh seedlings. Now there is death of 50,000 seedlings. Now in the field you have 450,000 plants instead of 500,000 plants. Calculate the percentage survival of seedling at fourth day. What percentage of seedlings have survived? Also calculate the plant-to-plant spacing if row spacing was kept 20 centimeter. So this is a very interesting numerical. You can see the answer. So if 500,000 seedling planted, the seedlings survived are 450,000. Then if one seedling is planted, then 450,000 divided by 500,000 and then 100 to convert it in the percentage. So you get 90%. Is it okay? 90% is the survival. It is very simple.
Yes, sir. Yes.
Okay, sir.
You must be laughing at it. It is very simple mathematics. But now things become complicated. Now you have been given plant spacing, plant to plant spacing of 20 centimeter. Then what will be spacing from seed to seed? So now you can see, I have also made one formula for your easy understanding. 100 into final population divided by initial population. You can remember this formula. 100 is for percentage, final population is 450 and 500, 90%. Then mortality or death rate, you can calculate 100 minus survival. So 100 minus 90%, so 10% is the death rate. Then mortality or death rate is equal to 100 into initial population minus final population divided by initial population. Now calculate the plant-to-plant spacing if row spacing was kept 20 cm. Now try to learn it. Suppose plant-to-plant spacing is Z centimeter. Thus plant spacing of one seedling. You know, this is the row-to-row distance and this is the distance between two plants. So we assume that this is Z centimeter. Z centimeter, so it becomes 20 Z centimeter square for one plant or one seedling. Okay, now 20 by 100, you need to convert it into meter. So to convert in meter, 20 by 100, because it is in centimeter. 1 by 100 Zm square. So it becomes, if you multiply them after dividing with 100, it becomes 0.002 Z meter square, converted to meter square. Okay, is it clear? Hope so. Then plant population meter square area in 10,000 meter square is the area. And we know the plant population of this area divided by plant spacing in meter square. Now plant spacing for one seedling is equal to area 10,000 meter square divided by plant or seedling per hectare. So in this case, 0.002 Z is equal to 10,000 divided by 5 lakhs and meter square cut by meter square in the above statement, and Z is equal to 10 centimeter. So I think your math is very fast. You must have understood this, but still if you have any problem, ask me. So now you see the plant-to-plant spacing has been found as 10 centimeter. The number of plants were given, how many plants are there in 1 hectare, 10,000 meter square. The row-to-row distance was 20 centimeter. And now we have calculated plant-to-plant distance. The answer is Z is equal to 10 centimeter. Your questions?
No questions, sir.
Is it fine and simple?
Sir, we
Yes.
will practice on that too, because this mathematical requires too many practice, so we can practice ourselves.
Okay, you will get more numerical. You will get more numerical.
Yes, sir.
You will get more numerical. See, this is also another numerical.
Okay, sir. We will just change only the figures. After that, we will just practice on that. If
Yeah,
you have
yeah.
any question.
Yeah, just 5 minutes more. Now, estimating plant populations. How to estimate the plant population? Plant population information is required to estimate the yields and germination rate. So as you know, the optimum plant population is needed. not too high, not too low. We need ideal number of plants per meter square or per hectare. If we get excess plant population, then there may be reduction in yield and quality. If we get too low or too little plant population, there may not be good yields. So estimating population density requires measuring the number of plants in a given area and converting them to per hectare basis. So after transplanting of rice, this is an example. If 80 seedlings are measured or counted in 6-meter row, 6-meter row length, and the rows are spaced 20 centimeter apart, what is the population density? So now you try to understand this question. You have done transplanting in the rice field. 80 seedlings are counted in 6-meter row length. In 6-meter length, you have counted 80 seedling, and row to row distance is 20 centimeter. What is plant population density? Means how many plants are there in a meter square, or how many plants are there in 1 hectare area? That is your question. If you can do it, please do it. If you do not know, I can tell you. Can you do it yourself, or should I explain it? Okay, now see how it can be done. Calculate the number of seedling in 1 square meter area, and then multiply by 10,000 to get result in number of seedling per hectare. Means very simple. First we can measure, we can count, or we can calculate the seedlings in 1 meter square area. And once we know for 1 meter square, we can convert it into hectares. So for example, 6 meter was the row length where the seedlings were counted, and the width was 0.2 meter. So 6 meter into 0.2 meter area have 80 seedlings. So therefore 1.2 meter square area, 6 into 0.2 makes you 1.2. So 1.2 meter square will have 80 seedlings. Therefore 1 meter square will have 80 divided by 1.2 seedlings. Therefore 10,000 meter square will have, you multiply it by 10,000, then it is something like this. 6,600, you can say 6.66 lakhs or 6.67 lakhs, or you can say 0.67 million. So this is how we can calculate the population. And then if you want to remember, this formula can also be used. This formula is very simple. Plant population per hectare is equal to 10,000 into number of plants counted, how many plants were counted, and meter square area from which plants counted. So here in this case, 10,000 is area, 80 plants were counted, from this, and 6 meter row length into 0.2. So 6.7 lakhs. If plant population of rice seedling in a hectare land is 1,60,000, find out the row to row distance when plant distance is 25 centimeter. So this is again interesting, and it can be done. I have already explained you on that basis. And this is all for today. Now I can invite your questions. If you have any question, you are most welcome. And I will be happy to answer your questions.
Okay, sir. I have just one question about this plant population.